Good morning, everyone. Let's take a look here. 2.6 Part 1 notes. Um, Piecewise Functions, guys. Sorry for the quality here. This was scanned as a PDF and a little tough, but we can still read here. So, piecewise defined functions. The function relating income. Yeah. So, income and tax, guys. That's a piecewise defined function. It's not linear because each interval or piece of the function is defined by a different expression, guys. So kind of the way this works, and this is just an example. You can get concrete examples from the IRS. But so say if you make $0 to $35,000, perhaps the income tax is, just as an example, 20%. Okay, and then so that piece of the function is defined by the 20% tax. Well, obviously some people make over 35,000, so those people that's a different piece of the function. Maybe they 35 and 35.1 thousand to say 70, just as an example. Maybe those people are taxed 25%. Okay, and so on. So the income tax, guys, that is what's called a piecewise function. Okay, and we're going to practice graphing piecewise defined functions. And so what this looks like, okay, if we've got a graph, an x and y axis here, or rather, let's use our algebra 2 notation here. X and f of x. Okay. We need to have a few points here. Mainly going to focus on the negative part of this graph. I'll describe y here in just a few seconds. Okay. If you're looking at the function, this reads f of x equals x minus 2 if x is less than -1. Where is x equals -1? X equals -1 is this vertical line here. Okay, and for this function, it's going to actually be our boundary. Okay, so x is less than -1. That function is defined for values like -2, -3, and -4 to the left of that boundary line. Okay, the other function, x plus 3, if x is greater than or equal to 1, so or -1 rather. So numbers like 0, 1, 2, those x values are going to be defined by x plus 3, that part of the function. So what do you do? Okay, we got this idea, we got this boundary here. Clearly at -1, something is going on. Okay. Let's make a table of values here. Okay. So for x values, let's plug in -1. Let's plug that into x minus 2. That's going to be -3. Okay, so -1, -3. That point there, is the boundary for our x minus 2 function. Okay, we have to pick values that are less than -1 to plug in. So we could plug in values like -2, -3, -4. Any of those values to the left. If we plugged in -2 to, again, this x minus 2 function, we'd have -2 minus 2, that is -4. So that's a point. -2, -4 is a point. So this function, guys, it's a line. X minus 2, that's a line, is defined there. Okay, I used an open circle, guys, if you noticed here, when I put my point here, I used an open circle. It's the same idea when you're writing your inequalities. Okay, this is strictly less than -1, so there's not actually a point there at -1. Okay, that's kind of where it starts, and it and it's defined by that line going to the left. Okay. For the red function, let's make a table here of values. The x plus 3 function, that's defined where x is greater than or equal to negative 1. So if we plug in negative 1, we would get what? We get negative 1 plus 3. And that's equal to 2. Negative 1, 2. Okay. This is going to be a filled in dot because, again, it's greater than or equal to negative 1. And then now we're going to pick numbers that are greater than negative 1, so 0. 0 is greater than negative 1. If we substituted that in, we would get 3. So 0, 3 is a point on that line. Okay, this piecewise function, guys, it's defined by two pieces. The piece to the left of the boundary, okay, the black function, and the piece to the right of the boundary, the red function. Okay, we can plug in points to either. Okay, these points, the x values we had to pick were less than negative 1. We plugged in negative 1 to see where it was on the line, but again, we left the open circle. Okay, the red function, we had to pick numbers that were x's that were greater than or equal to negative 1. Okay, so we'll kind of repeat that process, guys. Here, the boundary is going to be at 0. So let me get a graph started for us here. We're not going to need a great deal of points. Okay. So the boundary is x equals 0. So that is right along the f of x, or traditionally our y-axis. So this is going to be the boundary. So to the left of it, or less than it, it's going to be defined by, use another color here, x plus 2. It's going to be to the left, less than 0. To the right of it, it's going to be defined by x. It's again greater than or equal to 0. So we'll use blue. Let's do that left part first. Certainly our table doesn't need to be that big. We only need a couple of points. These are linear, so only need 2 points to make our line. X plus 2, so x is, let's plug in 0 again. We need numbers less than 0, so we'll do an open circle when we do get 0, but substitute in 0, we get 0 plus 2 is 2. So 0, 2 is, that's going to be an open circle point for this function because it's, again, strictly less than. And we got to pick other numbers that are less than 0, so let's plug in negative 1. Negative 1 plus 2 is 1. So negative 1, 1 is a point. So that's the line, that's the left part of our graph. Okay, the right part of our graph, this green one, we want numbers that are greater than or equal to 0. So we can plug in 0. It'll be a filled-in circle this time. So substituting in 0 for x, guys, the function is just x, so we get 0. So 0, 0 is a point. Okay, what if we plugged in 1? Okay, well, again, the function is just x, so 1, 1. So that's going to be the right part of our function. Okay? So that's how you get graph piecewise defined functions. Guys, on your homework, because again, you're wanting to identify that boundary. This one's going to be similar to that last example we just did. Okay, here the boundary is going to be at 2. So your boundary is going to be at x equals 2. So this would be your boundary line on number 2 on the homework. Okay. On number 3, the boundary is negative 1. So more similar to that first example. Guys, this one, the function's a little more complicated. Looks like it's a linear equation with a slope of negative 2 and positive 2. So slightly different examples, but similar. I'd like you guys to try all 3 for your homework again. The boundary being the biggest part of this, determining what values you can plug in. Open circles, closed circles, that type of stuff. All right, thank you guys for watching. I'll be glad to answer questions when we're back in class on Tuesday. Okay, we're going to have a good weekend.